It says Conic sections review. I know you feel like this may not be much of a review for you, depending on maybe you studied it more in algebra than I thought you have, or some of you may have encountered it in another class, but I'll show you what you need to know for calculus. Before we do that, notice that there's answers at the end of this worksheet here. Let me go to another page, and here's our formulas. For a parabola, you're used to this formula. Y equals a times x minus h squared plus k. Follow your variable. H is paired with x, so it goes in the front, and that would be your vertex. This is a stretch. These go up or down. You study these heavily in quadratics. But also parabolas, you'll encounter some in calculus that go sideways. And not that you need to memorize the formula. You know about transformations. But since this is paired with y, this is an up or down movement. And this would be still your vertex. But watch what it's paired with. When y is squared, they go to the side, left and right. A circle, you've studied before. The formulas that it's the most helpful is x minus h squared, y minus k squared equals the radius squared. If you have this, you know the center and the radius. If you have it in standard form, you want to get it into this form so that you can see what to do. On an ellipse and a hyperbola, you're going to have something like x minus h squared plus y minus k squared. The best thing to do is get it equal to 1, and then you can see how far to count using these numbers. It depends. If this one's bigger, then it'll be bigger along the x-axis, elongated. If this one's bigger, because it's under y, follow your variable, it would be bigger this way. This would be the major axis, would be horizontal. Here the major or longer of the two axes. Those are two different things, by the way. I made them look like they were. So if the letter under x is bigger, it would be bigger horizontal. If the letter under y is bigger, it makes sense. It counts up and down bigger. And the longer one's the major axes. Along here are things called foci that you don't really see, but it's what we talked about a bit in class today. They determine the shape of the ellipse depending on how close your foci are together. A hyperbola has this with a minus sign. But it could have y in the front. Follow your variable. And I'll be talking more about the hyperbola when we get to it. But if x is in the front, we'll talk about your hyperbola will go sideways like this. If y is in the front, your hyperbola would be more vertical. Okay, so these are what you're required to do if you follow along with the worksheet that I've posted. All right, to identify the conic section, I see that there's two things squared. So as I'm choosing between parabola, ellipse, circle, and hyperbola. It's not a parabola since the x and the y are both squared. It's not a hyperbola because there's a plus sign. It's not a circle because these coefficients are different. And so I would pick ellipse. The center of the ellipse, I'll be saying all lesson here. The center, follow your variable. What's paired with x, this would actually move it back 2 and up 4. What do I mean by it? If you had something simple like x squared over 25 plus y squared over 4 equals 1, this means there's no shifting. If you had this, it would be centered at x minus 0 squared and y minus 0 squared. And across, under the x, you would count out 1, 2, 3, 4, 5, and back 5. On the y, since it's under y, you would count up 2 and down 2, and you would draw your ellipse. Now what's going to happen with the one we do is it's actually going to go back 2 and up 4 before it ever starts its journey. So Anyway, what I do is I start to graph as I find things. I know it's an ellipse. I found my center at -2, 4. And so that's what this tells me. This number under the 25 tells me to go across, because it's under X, from my center, 1, 2, 3, 4, 5. And I'm going to go back 1, 2, 3, 4, 5. Then I'm going to go up and down on the y-axis 2. A lot of teachers and sites teach you to fill in all these blanks before you do the graph, but for me it's a lot easier and more intuitive to graph it and then fill in the blanks, because I know what I just did. Alright, so if I want to name, these have vertices. This has 4 sets of vertices. I would call these the major vertices because it's on the long axis, and these are the minor vertices. The ones I'm going to name right now on this are the major vertices. And I can actually see that I counted from -2, I counted across 1, 2, 3, 4, 5. So I know this dot right here is 5, 4. And I know this dot right here, I counted back 5, and so that would be -7, 4. If somebody asked you to name the minor vertices, you could also name these. These are at 2, 6, and 2, 2. You can actually see them. You don't need some formula. Remember, if I give you some of these to do on your own, you can look down here for the answers. Okay, and I'll probably be scrolling down to check just to make sure I don't make a careless mistake. Oh, I did already. I think I said it and didn't write it correctly. I'm glad I checked. That was 3, 4 right here. So it was across 5 from -2. So it went across from -2, 1, 2, 3, 4, 5, for a result of 3, 4. The foci, I don't remember if I've ever had to find those in calculus, but to find the foci of an ellipse, the foci of an ellipse are like the whispering chamber. They're somewhere in here. And where the foci are centered in the ellipse, or located in the ellipse, determine the roundness of the ellipse because of how the ellipse works, where it's equidistant from the foci. So the further apart they are, the more elongated your ellipse is. And so I'll just show you once how to find the foci. To find the foci, you subtract the bottom 2 numbers if you have it in this vertex center form, and you get 21. And then if you square root 21, you get 4 point something. Let's get my calculator up. So if I square root 21, I'm going to count 4.582, or about 4.6. Alright, so which way do I count? Do I count across or up and down? Follow your variable. Wherever the biggest number is, it's under X. So I go across the square root of 21. After I subtract, I square root that number. And I'm going to go across 4.6-ish. So I'm going to go across about 4.6 for my foci. 1, 2, 3, 4. It'll be really close to these vertices way out here. So my foci are the 2 dots inside. And if you had to name them, you know that you were at -2, and you counted to the right square root of 21, and you're still up 4. And then your other foci, you counted to the left square root of 21, and it's still up 4 units. Again, I think in the answer sheet here it's in exact form, and so you can see their answers here. Alright, the next one, let's talk about number 2. By the way, you're not required for me to say the foci. I just need to tell you what to do if it's on an ellipse. After you're finished, you subtract the numbers and square root. Okay, this is a parabola because only one thing is squared, but it's not in a good form to actually graph it and find the vertex. This is a parabola because only one thing is squared. Since x is squared, it's a function that goes up or down. In this case, this one will go up because of the lead coefficient. Alright, so you have 2 choices to find the vertex of the parabola. You can use -b over 2a, which may sound vaguely familiar from your algebra class. -b over 2a gives me 8 over 4. And so the front of my vertex is 2 because this is in terms of x. Now to find y, I'm going to fill 2 in for x. So that gives me 8 minus 16 plus 4, which gives me negative 4. So now my vertex is 2, negative 4. You would need to know that. You'll learn in calculus why negative b over 2a works, but you probably did it in algebra. If it's in terms of x, when you do negative b over 2a, you're finding x. If it's in terms of y, then negative b over 2a would be given your y value, and you can fill in to find x. Alternative number 2 is completing the square, which don't be worried about it. It's pretty, again, intuitive. Let's complete the square. To complete the square, I group my x's or my y's depending on the case that I have it. And this 4, you can either scoot it out or put it over here. You can add it to the other side temporarily if that's more helpful. You can like move it over here. For right now, I'm just going to scoot it out of the way. I'm just going to like leave this hanging out at the end. Then I'm going to factor out a 2, and that gives me x squared minus 4x. Completing the square, you take half of the middle number, which is 2, and then you square it. So I'm going to add in a 4. But now be careful on this equation. It's an equation, it's balanced, so I need to keep it balanced. And so I didn't have this number before, I just added it in. So I need to add something to this side too. However, it's not really a 4, it's really a 2 times 4. So I need to put an 8 on this side because I actually added an 8 on this side. Now I'm going to solve for y. This I can write as x minus 2 times x minus 2. That's why it's completing the square. And then I'm going to subtract this 8 from this 4, and I get minus 4. So now you can tell what's paired with x. Change your sign, and that would be 2, and that would be negative 4. You can see your vertex here. This 2 gives you a stretch, and since it's positive, it's going to go up. I'm not going to go over how to find the focus and the directrix. But to find them, directrix is a line behind it or underneath it or above it. The focus is a point above it, and it determines all the points on your parabola. Like if you go this far from the focus and this far from the directrix, you get a dot. If you go this far from the focus and this far from the directrix, you get a dot. If you go this far from the focus and that far equidistant, and it starts to make a parabola.